We have just covered a few key points about mud additives and the properties that mud should have to allow successful drilling. On the rig, it is important for crew members to constantly monitor and maintain these properties. An important member of the drilling team is the mud engineer. The mud engineer runs tests on the drilling fluid. The mud engineer's job is to monitor and maintain the mud's properties to the specifications of the well operator. He may also recommend changes to improve drilling, such as adding more caustic soda to increase the mud's pH. In this section, we will learn about tools that are used to monitor mud properties. The density, or weight per unit volume of the drilling mud, determines how much hydrostatic pressure the mud column exerts on the formation. It is therefore important to know the mud's density at all times. To determine mud density, the mud engineer or helper uses a mud balance. The person weighing the mud puts a small amount of mud in the mud container at left on the balance. He then slides the adjustable counterweight to the right or left until the arm balances on the fulcrum. The person then reads the mud density at the point on the arm next to the counterweight. In many areas, mud density is read in pounds per gallon, but can also be reported in pounds per cubic foot, milligrams per liter, and other units. Mud density is usually called mud weight by the rig crew. Calculate the density of mud by adjusting the counterweight on the mud balance. Click on the correct density when you're finished. Good job! The viscosity of the mud, its thickness or resistance to flow, is also an important factor. The mud's viscosity determines how well it can carry cuttings up the hole. One measure of a mud's viscosity is its funnel viscosity. That is, how many seconds does it take exactly 1 quart of mud to flow out of a special funnel called a Marsh funnel. A Marsh funnel has a hole in the bottom that is a standard size. The mud engineer, or helper, pours 1 quart of mud into the funnel and records the time it takes to run out into a pitcher or beaker. In this example, 1 quart of mud flows out of the funnel and into the beaker in 35 seconds. So this mud has a funnel viscosity of 35 seconds. A less viscous or thinner mud would flow through the funnel faster. A more viscous or thicker mud would flow through the funnel slower. This device also measures mud viscosity. It's a more scientific viscosity measure than the Marsh funnel. A Fann VG meter measures the mud's viscosity in centipoises. A centipoise is a unit of measure for viscosity, just as an inch is a unit of measure for length. The Fann VG meter works by spinning a rotor or bob in a sample of mud at 2 different speeds. In addition, a Fann VG meter is used to determine a mud's yield point, which is a measure of the mud's resistance to flow. Combined with a timer, the meter also measures the mud's gel strength. Gel strength is the mud's ability to temporarily solidify or gel when it is not flowing. Here is a mud with a high gel strength. Click the button labeled Lower Gel Strength to see what would happen if the gel strength wasn't as high. This is a filter press. Inside the white container is a piece of porous paper called filter paper. Also inside the container is a mud sample. The mud engineer puts the mud sample under 100 pounds per square inch of pressure for 30 minutes. The pressure forces the liquid part of the mud, the filtrate, through the filter paper and into the graduated cylinder. By measuring the amount of filtrate, the mud engineer can get an indication of the amount of filtrate that will be lost to downhole formations and the amount of solids or wall cake buildup on the wall of the hole. Mud engineers may run other drilling mud tests. One common test is for salt or chlorides in the mud filtrate. By adding potassium chromate and other chemicals, the engineer can determine if the hole has penetrated a salt formation. He can also determine whether salt water is a well bore, which may be a sign of a kick.